Today we're going to talk about limits of measurement, just going to tie everything in, everything from sig figs to a measurement lab and things like that. This will bring everything together, and this is how we're going to use all of that stuff. So a couple things you need to know first is the definitions. Accuracy, the closeness of a measurement to the actual value. So if something is supposed to be a meter long, how close did you measure that to a meter? Did you get 0.97 or were you way off? Accuracy, something you know of, think about playing darts. How close were you to the bullseye? To measure accuracy or to call something accurate, you only need one measurement. That's different from the next term we'll talk about. And then example here, I kind of just alluded to that. If you measure a whiteboard to be 0.998 meters and its actual length is 1 meter, that is accurate. You're close to what it should be. Next one here, precision. Our second vocab word. Precision is a gauge of a couple of things. How exact a measurement is, and this is determined by what tool or what piece of equipment are we using. So how close are those graduations together, or even are we using the electronic balance? How many decimal places is it giving us? Also, we can say something is precise by if we have a group of measurements, how close that grouping is to each other. So how close measurements are to each other. But to have this, or to be considered precise in our measurements, we have to have multiple. So a couple of trials will help us show precision. Something to look at to help maybe kind of set these terms, that bullseye. Here, 4 shots, 4 darts, whatever you want to call it, they're spread apart. There's not a nice cluster, and also we missed the target. We missed the bullseye. We missed the middle. So this one is neither accurate nor precise. This one down here, we missed the center, what we were aiming for. So it's not accurate, but all of our measurements or all of our shots were really close together. That's precise. That's the second part of that definition we gave you. Looking at these, close to the center where we were aiming for, but not quite the good cluster we're looking for to be considered precise. We'll look down here, last, all of them around the middle, so it is accurate, and there's a good cluster, or if you're into like gun sports, call those groupings, have a nice tight grouping. So both accurate and precise here. So sig figs and precision. Everyone's favorite, sig figs. To get correct sig figs when we are reading these instruments is going to be very important. We'll use this in lab a ton, and it's something I do expect from you because it is something we're going to show you how to do. To get correct sig figs when measuring, we use all of the known digits, so kind of whatever line that we know exactly, and then we can estimate an extra digit. So there is a little human component to this. But to give you an example, graduated cylinder. In this case here, graduated cylinder is marked every 1 milliliter. So I know that, okay, this is 3, so that's my known. And then there aren't graduations in between. Some pieces of equipment have graduations in between, and then we could get another one. But since I don't know, I can make an estimate. So this is how we show an I in chemistry. You'll see it in organic a lot. But if I look directly at, and this is what we call a meniscus, that bubble that's caused by the interaction of the water in the graduated cylinder, we read from the bottom of that bubble, and from the bottom I said it was 4, so 3.4. You could have read it differently and said 3.5, that's okay. So correctly reading this, it's not just 3 milliliters, it's 3.4 milliliters. Even if it was, the meniscus was down here at the bottom, even if it was there, we still wouldn't read this as 3 milliliters. We'd read this as 3.9 milliliters. Important that you do show as precise as you can without guessing more. Little disclaimer here, this only works for things that aren't electronic, like our electronic balance. We put something on there, it gives us those decimal places. It's doing this estimating for us. We don't have to add an extra digit, because how are you going to do that? What are you looking at to figure out, what's it in between type thing? So only works for things like graduated cylinders, burettes, beakers if we ever use them to measure volume, which you probably shouldn't. And then I can't think of any other piece of equipment. Mainly graduated cylinders is what I'm looking for here. Oh, rulers. Rulers also count. We can guess in between centimeters and millimeters and things like that. We can make an extra estimate. Some other things, precision of a calculated answer is limited by the least precise measurement. It's basically limited by which one has the fewest sig figs. Something we talked about before in terms of plus and minus, multiply and divide, those rules. So in general, the more decimals, the more precise the measurement. Example, if I measure using one graduated cylinder 3.5 milliliters, and then we measure using something else, maybe it was just a graduated cylinder that had a lot more spaces in between with graduations, that gave us a couple more decimal places. This one's definitely more precise, so this one is our limiting. This one limits our answer. Again, we've done this problem before, 3.5 plus this, fewest decimal places here. So when I report my answer, I can only report one decimal place. Last little bit here, just an example, something you will see in lab, something like this. We'll weigh a beaker, and then we'll put something in it and weigh it again. So suppose you weigh a beaker and find its mass to be 48.97 grams. Your partner measures out 1.002 grams of sugar. That was probably on a different scale or a different balance because it gave us different numbers of sig figs, but then adds it to our beaker. Whose mass is more accurate? So it's asking us a couple questions here. And then what is the total mass of the beaker and its contents? To answer your first question, whose mass is more accurate? I don't know, because think about that definition of accuracy. Do we know what that beaker is supposed to weigh? It doesn't say anything in here. Same thing with the sugar. The question is meant to trick you. The question, is trying to figure out, do you know the difference between accuracy and precision? If the question read whose measurement or whose mass is more precise, then you know, because it's the one with the most decimal places. It would be the partner that weighed out the sugar. Make sure you know that definition of accuracy versus precision. To get accuracy, you have to know what it's supposed to be. You have to have a kind of standard value. Question 2, what is the total mass of the beaker and its contents? Well, I'll let you do that with a calculator, but we can only report this to, again, that least precise measurement, those fewest decimal places. So make sure you do round to the correct number of sig figs using your rules for, in this case, addition.